So we're going to learn how to determine the determinant of a 2 by 2 matrix. So first things first, a 2 by 2 matrix. So a 2 by 2 matrix is a matrix that has 2 rows and 2 columns. So for instance, this is a matrix A, and this matrix has 2 rows, so rows run from left to right, and it also has 2 columns. The determinant of a matrix can be represented as this. We can also do it like this. So if we ever find a determinant of a 2 by 2 matrix A, what I like to think of is a crisscross. I like to call it crisscross. So we are going A multiplied by D, take away B multiplied by C. So whatever number is here, we multiply it to this number. So it's going to be A times D, and we're going to subtract that from B times C. So therefore, the determinant in this case would be whatever A times D is minus what B C is. And once we get that value, that is considered to be our determinant. Therefore, we can now take this determinant to calculate any questions related to determinants, or if you want to determine the inverse of a 2 by 2 matrix. So another thing we need to know about determinants of a matrix, if the determinant is equal to 0, so let's say for instance this matrix A, so if the determinant, remember our way of writing it, is equal to 0, matrix A is said to be singular. If the determinant of A is not equal, so this here means not equal, so it's not equal to 0, matrix A is said to be non-singular. So in other words, if the determinant is any number but 0, it's considered to be non-singular. I know it sounds weird when you think of the word singular, you think of 1, but in this case, when we say a matrix equals to 0, that means it is singular. So we're going to go into some questions that are going to help us to understand the concepts here of singular and non-singular matrices, as well as how to calculate the determinant of a basic 2 by 2 matrix. We'll also see how signs can affect the questions as well, so that will give you a better understanding of how to maneuver in different situations. Alright, so let's calculate the determinant of matrix S below. So we do what I like to do, the crisscross. So 5 times 3, take away 4 times 2. Now let's get in the habit of using our symbol that shows us determinant. So this here means the determinant of S. So we'll use the same concept like we did earlier. 5 times 3, take away 4 times 2. I like to put these in brackets because sometimes you get negative numbers and you have to be very careful with what you get with those. So we'll see some in some examples that we do later on. So for instance, in this case, we say 5 times 3 is 15 minus 4 times 2, which is 8. So what's 15 take away 8? 15 take away 8 is 7. Therefore, our determinant here is 7. Now, the fact that the number is 7, we could also say this matrix S is non-singular. Remember, we said it's non-singular when the number of the determinant is not equal to 0. The only time it is singular is when the determinant is equal to 0. So our determinant here is 7, and we know that this is a non-singular matrix. Alright, so our next example says use matrix T below to calculate this. Now looking at this, it's kind of like, what is that? What does that mean? Remember, we learned today that once we have it written like this here is telling us the determinant of T. So this is just a fancy way of saying calculate the determinant of T. So we do the same thing again, crisscross, going from left right to this corner on the right, and then we do negative 5 times 1. So therefore we'll have 3 times 7 minus, don't forget what I told you to do, the brackets, minus negative 5 times 1. So 3 times 7 is 21, and we're going to be subtracting negative 5 times 1. So negative 5 times 1 is what? Negative 5. So then here, look at what we have. We have a minus and a minus next to each other. So in this case, we'll end up with 21 plus 5. Only reason it became a plus is because this minus that we have here. So 21 plus 5 is 26. So therefore, the determinant of T is 26. And again, the determinant here is not 0. So because it's not 0, we can say it's non-singular. So matrix T is non-singular. So we are just doing this so we can reinforce a concept of understanding singular and non-singular. In another video, we'll use these concepts to help us to calculate some algebraic forms of this question. So example 3, determine whether matrix E is singular or non-singular. So this is another way of telling us to calculate the determinant without telling us calculate the determinant. So when I'm looking at this, it says determine whether matrix E is singular or non-singular. The only way for me to do that is to calculate the determinant. If I calculate the determinant, I will be able to identify whether it's singular or not. So we do the same thing again. We multiply going from left to this way, crisscross again. So 6 times 4, then take away negative 8 times negative 3. So the determinant of E is equal to 6 times 4. What do we not forget? Our bracket. So 6 times 4, take away negative 8 times negative 3. Now, 6 times 4, what is 6 times 4? 6 times 4 is 24. And we're going to subtract negative 8 times negative 3. Now, what is negative 8 times negative 3? So negative 8 times negative 3 would give us positive 24. The reason why is 8 times 3 is indeed 24, but once we multiply a negative times a negative, it becomes a positive. So I know that these two numbers would give me 24, and I would have 24 minus 24. So what's 24 take away 24? That leaves us with 0. So in this case, the determinant of E is actually 0. Now what does that mean for us? This tells us that matrix E is, that's correct, singular. So how do we know it's singular? Because the determinant of E, written just like this, is equal to 0. Remember also, another way of writing it would have been like the determinant of E. Alright, so for this question, we're going to write an algebraic expression for the determinant of matrix N below. So same thing again, we're going to go this, crisscross, x times 5 from left to right, and then crisscross again, negative 2 times 4. So now we would have x times 5, remember we put that in brackets, and we subtract negative 2 times 4. So x times 5 is 5x. We usually write it like this, 5x. We put the number, or what we call the coefficient. This is called a coefficient, and this is called the variable. So when we multiply them together, we put the coefficient in front first. So we have 5x minus, and this says negative 2 times 4. Now a negative multiplied by a positive gives us a negative. So therefore we would have negative 8 here. So we'll end up with 5x minus negative 8, which gives us what? Plus 8. Now the reason we got plus is like our question before, that we had two negatives together. So the reason we did that, because we have a minus and a minus, which turns to a plus. So the expression for the determinant of N, or determinant N, is equal to 5x plus 8. So hopefully this gives you a good understanding of the basic idea of calculating or expressing the determinant of a 2 by 2 matrix. This ain't no play man thing. This is serious business. Continue to work hard, continue to grow, continue to get better, and don't give up. We make adjustments, not excuses. You'll get there one day.